Well, here in this video, we would like to solve a problem basing on current density. So first of all, we shall remember back what is that current density is. We know current density is defined as, which is represented with a J, di by ds, where ds is very small and it is also a kind of a scalar quantity. Now, that current density J is given to us in the problem as alpha plus beta R here. When it is driven through a circular loop of radius R, let me try to draw a diagram for that. There is a circular loop and the radius of that circular loop is R, capital R. So from here to here, it has a radius R. And R being the distance of a point from the wire axis. So this is the wire axis. What is the current through any of the cross section of the wire is the question. So we shall first of all find out the value of the current through a small part and then we will apply it to the entire section itself. So let us imagine another small circular cross section. This is the small circular cross section that we are taking into consideration. This one. Let this circular cross section is at a small distance r, and this circular cross section is having some thickness. This one. This is having some thickness. Let that thickness is equal to dr. In that case, first of all, we would like to find out, as we want ds, area of that small part. Let's try to find out the area of that small strip. How can I get the area of the strip? This area I want. I can say that's the area of the bigger circle, that is this circle, minus area of the smaller circle. What is the area of the bigger circle? Pi, distance from here to here. You know, up to here the distance is r. From here to here the distance is dr. So the total distance is r plus dr whole square. Minus area of this inner circle. Inner circle is at a distance r, pi r square. So if you simplify this, pi a plus b whole square is a square plus b square plus 2ab minus pi r square. So if we simplify this further, pi r square, pi dr square, 2 pi r dr minus pi r square this term. So this pi r square and pi r square gets cancels. Dr is a small value, so dr square becomes even smaller and that value can be ignored. Therefore, the area, of course with a little bit of approximation, is 2 pi r dr. So the small strip is having an area of 2 pi r dr. Now I can write from the above formula that we have written, di by ds is the current density. That implies di is equal to j dot ds, where the value of current density is given for you j, ds we have already calculated. Now we are very much ready to substitute both of them in the formula. That implies from here di is equal to j means, as given in the problem, alpha plus br dot ds. ds is this value, 2 pi r dr. But be careful, that's the current calculated only through the small strip. This entire circular part is having so many strips like that. I want the total current. So, to get the total current, we shall integrate the equation. Integral of di is equal to integral of alpha br 2 pi r dr. Now integral of differentiation of I is equal to I. That's what our intention is to calculate. This is you can write multiply with r, alpha r beta r square and 2 pi dr. That's a simplification. So if you simplify this further, I equal to, I can take 2 pi out, integral of alpha r dr plus beta r square dr. I have just redistributed these words, these numbers. Then the value is 2 pi alpha. You know, the formula for the integral of x power n dx is equal to, we have learned this in mathematics, x power n plus 1 by n plus 1, that is r means r power 1, r power 1 plus 1 by 1 plus 1, that is r square by 2 plus beta, same formula, it becomes r cube by 3. So, and it has some limits. From where to where we have to cover the steps? From here to here. So, the value of that r could be 0 here. It could be maximum of radius of the entire circle itself. So, the limits are 0 to r. Here also I had applied the limits from 0 to r. So, it becomes what? 2 pi alpha r square by 2 plus beta r cube by 3, because the lower limit is 0. When you subtract that term, that becomes automatically 0. Hope you have learned it in basic mathematics. Then this is equal to 2 pi. If I have taken r square also as common, it becomes alpha by 2 plus beta r by 3. So it becomes 2 pi r square. Let's take an LCM. 2 and 3 has LCM of 6. 3 alpha 2 beta r by 6. So the value of the current through the circuit could be 2 pi r square. See this answer. See here. 2 pi r square by 6. 3 alpha plus 4 beta r is the correct answer. This is how we have to solve the problem. So to solve this problem, we shall know few basic things. What is that? We shall know what's the meaning of current density. Current density is being defined as rate of change of current with respect to a given surface area, right? And we shall also know that we have to calculate first for a small strip, and then we have to extend it for the entire circle by integrating it. So if you are familiar with these two concepts and a bit of mathematics, you can simply solve this problem, right? Thank you for watching.